Hi guys, welcome to your video for similar triangles. All right, so it says here in not the previous lesson, but in a previous lesson, we talked about two polygons and how they were similar by showing that all corresponding angles were congruent and all pairs of corresponding sides were proportional. So proportional doesn't mean congruent, but it means that they form a proportion. It is possible to prove two triangles are similar without knowing the measures of every angle and side. So we can use a postulate called angle-angle similarity postulate to prove that two triangles are similar. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So using this picture, we could say that angle A and angle F are congruent. So if those are congruent and then angle B and G are congruent, then the two triangles are similar. So we could say triangle ABC is similar to triangle FGH. So this little symbol right here means similar. It's just a little squiggly. Just like the symbol, the little squiggly that's on top of a congruence symbol. Congruence is like this. Notice how it has an equal sign because congruent means equal, and similar is just part of that. So not equal, but they are alike. They're like cousins, but they're not twins. Okay. All right. Now remember when we write congruent statements, we always want all the corresponding parts to match up. Same thing with similarity statements. We need all the congruent parts to match up and be in that correct order. So what we're saying here is that angle A is congruent to angle F, B is congruent to G, and C is congruent to H, and so on. Next, we have side-side-side similarities theorem. This tells us that if the corresponding side lengths of two triangles are proportional, then the triangles are congruent, or sorry, similar. So we can say if JL is proportional, or JL to MQ is equal to JK to MP, which is proportional to, or sorry, is equal to LK to QP, then these two triangles are similar. Now, notice how we're marking the sides. In this case, we're marking the sides for proportionality, not for congruency. So that's where it gets a little confusing, but hopefully we will clear up any confusion with this lesson here. So how do we label the two triangles as similar? We're going to say that triangle JKL is similar to triangle MPQ. You know what I'm thinking? I'm thinking that because they're just similar, we probably shouldn't write those markings on the sides. Let's not do that. So erase those. Okay, next theorem. It says side angle side similarity theorem. If the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So here we're saying that this angle and this angle are congruent. So we could say angle S and angle Y are congruent. And then they're saying the two sides. So like SR and ST are proportional to YX and YZ. So we can say RS over XY is proportional or equal to the proportion of ST over YZ, and angle S and angle Y are congruent, then these triangles are similar. SRT y, x, z. So just to explain these fractions here, we're saying that if RS is proportional to XY, and that proportion is equal to ST over YZ, that proportion or that ratio. So we're saying whatever this length is divided by this length is equal to this length divided by this length. Those are those proportions that we set up like this. And then we would like cross multiply, right? As long as we were like looking for one of the sides. In this case, we're not looking for one of the sides. We're just stating that this side divided by the other triangle side is equal to the same proportion as these other two sides being divided. All right, check for understanding. Determine whether the triangles are similar. If so, write a similarity statement. So again, the similarity statement is this down here, where we match up all the congruent parts. These are the similarity statement. Okay, number one, determine whether the triangles are similar. Okay, so it tells us that PQ and JK are parallel with that little triangle. So because they're parallel, we can see JL and LK as transversals. So we need to look at our angle relationships. So angle J and angle P would be congruent. And then these angles would be congruent. And because both triangles share angle L, that angle L is the same on both triangles. See, it's angle L on this triangle, and it's angle L on the second triangle. So here we have angle, 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 which was our first, or I'm sorry, angle, angle, I guess I should say. Angle, angle, because there's only two A's. Angle-angle similarity postulate says if two angles of one triangle are congruent to two angles of another triangle, then they are similar. So I guess we really didn't need to focus on this one. The fact that these two angles are similar or are congruent already is enough to tell us that these two triangles are similar. So we'll write our statement. Triangle LPQ is similar to triangle LJK. All right, number two. We have a bunch of sides here. We need to see if any of these sides are proportional, because if they are proportional, then we could use the side similarity theorem. So let's make some fractions. We could say that 8 and 12. So 12 divided by 8 simplified give us, okay, I see, my bad. 12 over 8 would be one proportion. Then we could do 8 over 5. And then the last one we would do 6 over 4. So we want to write a proportional statement between all three sides. And what I did here was I started with one triangle as the numerator, and then I put the second triangle as the denominator. It doesn't matter which one goes on top or which one goes on bottom, as long as you're consistent with one triangle being all the numerators and one triangle being all the denominators. You can't switch between them. So simplifying this proportion here, 12 and 8, this fraction is divisible by 4, so we'd be left with 3 over 2. 8 over 5 cannot be simplified, so it stays 8 over 5. And then 6 over 4 ends up being 3 over 2. So our next question is, are these fractions the same? No, they are not. This middle one is not the same as the others. So these two triangles are not similar. In order for them to be similar, we would have needed all three sides to be proportional. In this case, it does say side, side, side. So on the first one, we only need two angles, but here we need all three sides to be similar, or yeah, proportional. All right, let's scroll down. Number 3. Let me get some water. Hold on. Okay. Number 3, multiple choice. In the figure, AB intersects DE at point C. So it says it intersects, it's not a bisector. Which additional information would be enough to prove that these two triangles are congruent? So all we know is that this is an intersection, so we definitely can say that these vertical angles are congruent. We can gather that from the information being provided. So we don't need it to be said here in one of our options. So we know one angle is congruent, and we know that it, according to our three postulates, or sorry, postulates, on the last page, we have angle, angle, side, 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 or side, angle, side. So if we can only choose one more statement to make these triangles proportional, or sorry, to make them similar, the other information we would need is that another pair of angles are congruent. That way, these triangles would be proportional or similar through AA. So in this case, if they said DAC, this one, and ECB are congruent, that's this angle. That's not going to help us. Okay, not that one. AC and BC are congruent. That doesn't give us enough information, so not that one. AD and EB are parallel. So if these two sides are parallel, what do we know about the angles? We could say we know these are congruent. But if these lines are parallel, then these two angles would be congruent, and these two angles would be congruent. So this would definitely be possible through AA. As long as we have two congruent angles, we're good to go. So the parallel lines would help us get at least one more pair of congruent angles to prove that these two triangles are similar. Number 4, identify the similar triangles and find the missing measure. So it tells us that we have one matching angle at the 51, and then it tells us that we have another matching angle at J and X. So honestly, that's enough information for me to prove that these two triangles are similar. But they also give us these side lengths, so let's go ahead and write a proportion. The side lengths of one proportion should be 5 and 4, and the other one would be 15 and x. So now that we have to solve for a side, we're going to use that cross multiplication. So we have 5x equals 15 times 4, which is 60. So divided by 5, x equals 12, sorry. All right. The angles were enough to tell us that these are similar. The missing measure is 12. Oh, it says find the missing measure. So this side is 12. KL equals 12. Okay. The properties of similar triangles can be used in indirect measurement, which can be useful in solving real-world problems. Adam is standing next to the Palmetto Building in Columbia, South Carolina. He is 6 feet tall. Okay, already sounds like we need a picture. Adam is 6 feet tall. And he's standing next to a building. The length of his shadow is 9 feet. Okay, maybe I need to fix this picture. The length of his shadow is 9 feet, and he's 6 feet. If the length of the shadow of the building, let's say the building shadow is this green color, and the building shadow is 300 and, let me just draw it up here, 322.5 feet. How tall is the building? Okay, so we have one triangle right here with Adam that has a side of 6 and a side of 9. Put this inside so it's a little clearer. And then we have the building, which we don't know how tall the building is, but the building shadow is 322.5 feet. So let's write some proportions. We're going to say x over 6 equals 9 over 322.5. Now, if you wrote your fractions backwards, maybe you did 6 over x and 322.5 over 9. When you cross multiply, you'll still get the same answer. So no worries if you did it backwards. So we have x times 322.5 and 6 times 9, which is 54. Divide by 322.5. Oh, I should probably get a fraction, but oh, I need a calculator for a fraction. I don't know if I can get a fraction here. 54 over 322.5 fraction. Okay, this fraction simplifies to 36 over 215, which is the same thing as 0.167 and then some other numbers. Okay, so how tall is the building? That does not seem right. Maybe I should have done 6 over 9 equals x over 322. This is what happens when I don't finish my key. Sorry, guys. Let's check it the other way. Maybe I did it wrong. 6 over 9 equals x over 322.5. Yeah, I think this is going to be the way to go. Sorry. 9x and then 6. Wow. 6 times 322.5. Yes, this is so much better. 1935. All right. So sorry. Divided by 9. By 9. 215. All right. Here's a good answer. Not this one. So we wanted to make a ratio of one triangle to the other triangle. That way we can find that the building is 215 feet tall. Much better. All right. Okay. On the next page. Oh, I should have rotated this, but it's okay. On the next page, we have triangle similarity. This is just a little quick reference guide that you can use. So AA, angle similarity, if two corresponding angles are congruent, then the triangles are similar. Determine if the examples below are similar by AA. If yes, write a similarity statement. Okay, so let's see. 75, 31, we have two congruent angles, which means that yes, these two triangles are similar. So we'll say yes, and we're going to say triangle ABC is similar to triangle DEF. All right, number 2, we're given two congruent angles. We know vertical angles are congruent. Two angles congruent in two triangles is enough to prove that they are similar. So we'll say triangle VWX is similar to triangle YZX. And maybe you wrote your letters in a different order. As long as they match up with the congruent parts, we are good. Next one, side-side-side similarity. If all corresponding sides are proportional, then the triangles are similar. All corresponding sides. So let's check our proportions here. We have 3/6, 5/10, and 4/8. Let's simplify these fractions. So 3/6 ends up being 1/3. 5/10 is, oh, I'm so sorry. That is not 1/3. What am I thinking? 3/6 is 1/2. 5/10 is also 1/2. And 4/8 is 1/2. So yes, these are similar. We can say triangle QPR is similar to triangle TSU. All right, for number 4, another one, 30/24. 32/25. 35/28. All right, 30 and 24. We get 1.25. 32/25. We get 1.28. 35/28. Okay, so this is 1.25. You can always do decimals and just see if the decimals match. You don't have to simplify them always. Let me double check. 32/25. Yeah, that's 1.28. And then this other one was 1.25. So this is the one that's going to be getting us to be not similar triangles here. So here we're going to say nope and move on. Last one, side angle side similarity. If two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. All right, so the included angle is congruent. We need to see if these are proportional. 8/6 and 20/15. So let's see, 8/6 is 1.3 repeating. And then 20/15 is also 1.3 repeating. So these are proportional, or sorry, they are similar. We can say KJL is similar to triangle oh, sorry, I wrote that wrong. NMP. Now, number 6. Okay, we have two triangles inside of each other, and angle A is the same on both triangles. So we have an included angle that is the same. Now we need to see, is 12/21 proportional to 15/25? Let's check our decimals. 12/21 is 0.5714. And 15/25 is 0.6. Those are not the same, so these are not similar. All right. On the next page is your homework number 4. This homework is due on Wednesday. Okay. So at the top, make sure you write due Wednesday. So when you are done with your notes today, I need you to get started on this homework. Tomorrow in class, we will have a work day. So you can work on this homework today or work on this homework tomorrow. But just please note that there are 1, 3, 6, 9, 10, 11. There's only 12 questions here. So if you're not done with homework 3, I would complete that now. If you are done with homework 3, then yeah, definitely start your homework 4. All right. Okay. Well, I hope you have a great day and I will see you.